Hello everyone, and thanks for stopping by and viewing. Here we have something a bit unusual. This is a circuit board from a baler, a Kverneland baler 2002, if I remember right. The story is that occasionally the signals from the proximity sensors fitted around the machine starts dropping out, and that's what I've been asked to have a look at and see if we can find out what the problem is. Prior to getting the board on my workbench, I went to have a look at the baler just to confirm the problem itself and to have a look at what was happening when the fault occurred. And the owner was telling me that he had found out when the fault happens, and you will see the LED lights from each of the sensor inputs, they would drop out. When that happens, if he blew compressed air in around this area down here, it would eventually come back. A while back it was good for a good long time, and now it's at a stage where it will only work when he blows air at it. The moment he stops, within a few seconds the fault is back. So highly likely we have either a component problem or a dry solder joint in this area here. So we're going to have a look at this and see what is in fact in this area, and what components have we got here that are relevant to this section. Found out about their normal behavior and try and take a couple of measurements and see if we can recreate the fault. So we have a measuring point here on the board which would suggest that we have positive voltage, likely 12 volt, but I'll confirm that in a second. You can see the writing there, plus VACCU, and there's a little point there. I expect there to be probably 12 volt. This component you have here, the yellow one called F2, that's a small resettable fuse, and they can fail over time, so that could likely be our problem. But we'll find out. We will try and trace where this fuse gets its supply from, and we will just check the voltages along the way up until this point here. This, I would imagine, is the same as the plus terminal on these terminal blocks. So I took a photo of the back of the circuit board and printed it out. It's just a bit easier than flipping the board all the time. If we look here, the measuring point I showed you before is that dot we have there, and between this point and this point we have the resettable fuse. So the supply to the fuse must be coming on the blue line that I've drawn here, which goes all the way up to a solder joint there, and I will show you that on the board. It's actually this point here. So that's where the fuse gets its supply from, and that means we should practically have the exact same voltage here as on the bottom leg of the fuse, and probably ever so slightly less on the other side, as there's always going to be a small voltage drop across a fuse because of its internal resistance, but it wouldn't be much. But we'll have a look and see how much it is. So we power on the board and we are good to go. So we will check this point here first. That's a bit, yeah, that's okay there. So 12.3, and this is the same as we expect now to see at the bottom leg of that resettable fuse, which is there. Yeah, so we have 12.3 volt coming to the fuse. Let's see what we have exiting the fuse. We have considerably less, but that is mainly because of the resistors I have connected to the inputs. They will draw down the voltage a bit. I'm not exactly sure they should be pulling it down that much. That could be due to the fuse starting to fail. But it will always be a little bit less. I think that there we saw there was a 10.6, 10.9. I think it's a little bit too much that we lose 1.5 volt just by that. But that remains to be confirmed. So the voltage test point I have up here is the same 10.9. That's close enough. It's an awful glare. 10.9, and that is in fact the same as the positive terminal on these 12 inputs here. So what I will do is I'll just connect the probe here, and then we can watch the voltage, what happens if I gently start to heat up that resettable fuse. So I'll start to heat up the resettable fuse here with a bit of hot air and see what happens to the voltage here. It's already beginning to drop, and I have it down at the lowest setting, so it's not like I'm overheating it excessively. There is also a chance that it could have been a wiring fault that that caused the fuse to trip out, and if it has tripped out continuously over and over again, that will cause internal fatigue to happen in the fuse, and it will need replaced. It could also be a faulty proximity sensor on the machine itself. But yeah, once you start to heat it a little bit, the voltage drops significantly, which is kind of what it's designed to do, but under normal circumstances. We're sitting at 8, and then we will give it a little bit of freeze spray and see what happens. And it's back up close to normal. It is now. Yeah, so if I cool it down even further, it nearly climbs up beyond where it was when we started. I will disconnect these resistors I have put in for the inputs and the 2 proximity sensors that I have connected, and then we can have a look at the voltage after and see what it is when there's no load on that circuit at all. That's them all connected now, so all that's left is the emergency stop, which I have pushed, but there is a permanent resistor built into that circuit, the one you see here. So even with the switch activated, it will still draw a bit of current through that resistor. So we will see a small voltage drop across the resettable fuse, but it'll not be overly significant. Let's see how much it is. So we have 12.37 coming in. And 12.23 coming out. So a voltage drop of about 0.15 volt, simply just because of that single resistor that serves as an active input 1. But we will replace that resettable fuse, because chances are it has suffered in the past, and that's why it's not functioning correctly anymore. And after replacing the fuse, when I go back to fit the board, I will be checking the current consumption of each of the proximity sensors to see if we have a faulty sensor that caused the problem to originate in the first place and subsequently caused the fuse to fail. And the easiest way to do that is run your positive supply through an amp meter back onto the positive wire for the sensor itself. And if you look at this one here, this is not the one out of the baler. This is just a cheap one of Amazon, so I would expect different readings from the actual sensor. But this one here is consuming 2.3 milliamp at rest, and if we activate it, it consumes just short of 4.4. And I would expect something similar with the other ones. Bear in mind that fuse is a 200 milliamp fuse, so it shouldn't really start to affect the voltage or reduce the voltage unless the current exceeds 200 milliamps, and that would be unlikely with only 12 inputs. So that's about as much as we can do today. I will get the resettable fuse ordered and I'll get it replaced, and the next will be to take the board back to the baler, get it fitted, get the proximity sensors checked one by one as we reinstall them, and hopefully that should have cured the problem.